talking about like Pokemon Go or something. Did you?
All right, so shh.
She's coming for her.
What's it called? The lesson.
You know, Pokemon is a rabbit or a rat, or is a rat or rabbit?
What are you talking about? It's like Pikachu?
Pikachu, yeah, Pikachu.
It's a mouse.
It's a mouse? Oh, it's a mouse.
Okay.
That's what I thought too. Anyway.
Yes.
So if you don't want me to come to you, you better ask other people questions.
You have to watch the video outside school. I don't like doing that. I don't like doing that, so you're right.
I want to review something that will be on Friday's test. Yes.
The test is Friday.
That's okay.
Wait, this part?
Yeah. We should
Like,
make it
in like.
All right. Shh. Yeah. So shh. You should know what is average value. Do you know what's average value? You already forgot?
No.
Integration between a to b of f of x dx.
Sorry, could you learn your screen?
Yeah. Average value. You have to know average value. You have to know what's the mean value theorem for integral. They are actually almost identical, except you evaluate different things. So integration between a to b of f of x dx is equal to f of c times b minus a. They are almost the exact same thing. If you look at it, if you divide both sides by b minus a. Now, instead of solving for 1 over b minus, instead of solving for the area divided by the width, you want to find out what c value is going to give me the height. So they sometimes have more than one value. Now let's talk about fundamental theorem of calculus, which is something that you'll always get tested on, especially part 2. So fundamental theorem of calculus is when you integrate something, let's say f of t dt, and between a to b, sorry, let me just use, should I use x or I should use x? Sorry, I'm gonna use x here. It doesn't matter. It's always equal to, so if we integrate a non-capital F, it's always going to get capital F of substitution, which is subtract each other, and that's a definite integral. You guys do this all the time. There's nothing change. F of b minus f of a. And that's a fundamental theorem of calculus. How many of you guys know how to use hammer and nail?
Like a hammer and nail?
And nail, like if I want to like nail something into the wall. Oh, okay, that's actually more than I think. Really? That's actually more. I thought this generation just doesn't know how to do anything. That's actually surprising. This is a good group of class.
You never use one. I was surprised you can't just like figure it out.
No, like sometimes you hit your finger. You don't know.
I like using a drill more because at that point you can just...
But and sometimes he doesn't know how to hammer it in straight because every time you hammer get bent.
My dad would get so mad when that happened.
Oh really? So your dad would teach you that?
Yeah.
That's really cool. Do you have siblings?
I have an older brother.
Okay, but he treat you like teach you like a boys.
Yeah.
Okay, that's cool. That's interesting. Am I gonna get canceled for saying that?
No.
Oh, that's good. I think I think my son's too weak. Like I want him to be like.
That's good.
Guys, moving on. Fundamental. Does it go off?
No, he's really like, he's really, I think he's really like, Mommy, I cannot, oh Daddy, I cannot open a water bottle. I'm like, dude, just open a water bottle, just
I
twist.
open a water bottle.
Really? Like, you know how like water bottle and like you cannot open. I'm like, dude,
Oh, like it.
he's like 11 years old. You cannot not open a water bottle at 11 years old.
Yeah, I'm getting a little off.
Yeah, no, I'm like, this is too weak. Get down and do 10 push-ups. And he can barely do one. I was like, Jesus.
Send him to do water polo. I'm telling you.
I'm thinking about it. I'm thinking about it.
They've got like a youth program now.
Yeah. I saw it, the sign next to Gotha, so I was like, yeah, I need to make this boy strong.
Send him up there.
Not
and
weak.
teach him.
Okay, so fundamental theorem of Calc 2. What is fundamental theorem of Calc 2? The theorem is gonna nothing look like question because the theorem actually give you the perfect situation. So if I ever integration of a to the x of ft dt. Now, why did I choose different variable? Just because I can. It doesn't make any difference. Now, if I decide to take a derivative after, it's always going to equal to f of x. Now, it kind of makes sense. If I take an antiderivative of something following with derivative, then it should go back to original function, right? Technically, this is what happened. F of x, because I take a derivative with respect to x, and the upper bound is x. I'm going to show you what actually did happen. Now, in a slow motion, this is what actually did happen. Let's say slow motion. So I like to break things down like slower to see, okay, what actually happened? What actually become f of x? Because your question might be different. This is a perfect situation, and you know my test never a perfect situation. So if I ever integrate this, right? Now I'm gonna rewrite this. I'm gonna copy this, and I'm gonna paste here. And let's just take one step at a time. Let's just take integration of this. What's integration of non-capital F? Capital F, yep. So it's going to be capital F of x. And between two boundaries, right? Between x and a. Does that make sense? And I'm going to take a derivative after that, after you plug in the boundaries. Yes.
Why is it f of x if it's like d? Like, you see what I'm trying to say? I know. I can give it.
Oh, okay. Sorry. It's ft. You're right. F of t.
Other one is f of t too, or is the other one soft?
No. It will eventually go to x because we're taking derivative with respect to x. I'm going to show you that. Okay, so what happened here, then the d to the dx still going to be there, right? And then that's going to give you a small, it's going to take a derivative. So I'm going to take f of x minus f of a. Once I did the fundamental theorem calculus, I sub one thing, subtract another thing. So far, are you lost?
Not lost.
Okay.
Check the derivative is what you're saying?
I take the antiderivative, then it become capital F. Then I do upper bound, subtract lower bound, then it's this.
Okay.
Now I'm taking derivative here. Now be careful, there's chain rule here. It's so emphasized. So if I chain rule, if I take a derivative of this, it becomes non-capital F. Does that make sense?
Yeah.
And there's a chain rule, which is, everybody forget there's a chain rule, 1. Because derivative of x is 1. It's very crucial that you understand this. Now, if I subtract it, that's going to give you f of a times the chain rule of a. What's derivative of a?
1.
No.
Oh, a. Da.
No. The a is a constant.
0.
0.
Oh, I didn't know it was. So didn't use f of x.
Yep. So it looks really nice. It looks like, oh, just go back to this. But there was a chain rule involved. This is a perfect situation. There's a chain rule involved. I'm going to remind you. There's chain rule involved, and this is only in the perfect situation. And I'm going to remind you, my test is never perfect. Yes.
So hypothetically, if it was like a trig and it had 2 theta instead of like just like theta, you see what I'm trying to say?
Yeah, there was a chain rule. There's a chain rule. So we're going to talk about that in a second. So on the homework question, that you might get some question like say this, and I remember I think there's a student that she passed my class, and she was in University of Chicago. And she said, Mr. Ed, she texted me. It's like, how do I do this problem? I'm like, I teach you like 6 times. How can you forget? I was so mad.
I got so mad, Mr. I got so mad on Saturday because I tutored this 8th grader for Algebra 1, and I was so mad. I felt like you, because we're like, okay, so it's factor, and he stared at me, and like, I was like, did you forget how to factor? He forgot how to factor
No,
over
it's pretty
a 2-week
no,
break.
it's pretty more normal. Like
I
kids,
know, but I got so mad. But I didn't get mad. Like, I didn't like get angry towards him, but I got mad because how can you forget how to factor over 2 weeks? But also, I've been factoring for a long time, so.
no, this generation is pretty bad.
Oh, you're not wrong.
No. The following generation is worse. And I'm gonna explain to you why it's worse because the teacher give out grades, like all the time, and they give free grades. Like for example, your algebra 2 teacher probably give you free grades, so you probably have 120 on your algebra 2 class. Shapiro did not do that. Shapiro did not do that, and that's why he got downgraded to algebra 2, which is that's sad. You cannot do that. You cannot baby kids says, oh, you're not strong, so it's okay to stay weak. I'll just give you an A. No, not. I'm not gonna give you an A. I'm gonna give you an F. I'm gonna give you a D. I'm gonna give you what you deserve, and then you grow from there. You learn how to stand back up, and that's the way I think about it. But anyway, that's my thing. So we have this, and we say, hey, can you find f prime of x? You're like, ooh, it's f prime of x. Now, can you pay notice of this? What is this unlike what we did before? It's not only a trig, it's an expression, it's not a constant. Right? So this and this all a variables, expressions, and not constant. It's not constant. It's not constant. Okay. So what I'm gonna do is, can you find f prime of x? Well, what do I have to do? I have to take a derivative on both sides, right? So that just say I have d to the dx of the black part, which is f of x, is equal to d to the dx of the black part here, which is equal to cosine of x sine of x square root 1 minus t squared dt. Now, for how it's worth is you actually don't know how to do integration of 1 minus t squared. Here's the reason why you cannot take it integration of 1 minus t squared. Because imagine u equal to 1 minus t squared. What is du? No. Negative 2t dt. But there's nothing for you to cancel. So you got extra negative 2t on the bottom. And there is no back sub you can actually integrate this. So you can actually integrate this. So anytime I see this kind of things, especially I have a boundary is an expression, what I will actually approach is set up something that we're gonna say is assume. And assume that this is ft is equal to square root 1 minus t squared. Now, I'm going to not assume f, I'm going to use g. The reason why I use g is because I don't want to confuse with this f. So I'm going to assume g of t is equal to 1 minus t squared. Now, obviously, if I take a derivative, this side is going to be f prime of x, right? And the d to the dx still in the front. And this black part of sine of x, cosine of x. And this is g of t dt. So that makes a lot nicer. So it turns out like I don't need to know how to take integration square root 1 minus t squared. I'm going to show you why I don't need to, because we already assume this is this. It's like use substitutions, right? We substitute this whole thing is this expression. We say, hey, let's take integrate of g of t. So how do I integrate a non-capital G of t? What is it? How do I integrate? Use fundamental theorem calculus. How do I integrate non-capital G of t?
Oh, it would be like sine. What?
No. How do I integrate a non-capital G of t?
Capital G.
Capital G of t. Good. Wow. Super hard, right? And so it's not a hard. G of t like this. And between two boundaries, well, we know it's sine of x and cosine of x. And we need to substitute that boundary, right? Are you lost? D to the dx. So still, that's the second idea. So this is fundamental theorem of calculus, which is g of sine of x minus cosine of x. Big G of cosine of x. So far, are you understand? So this is a fundamental theorem of calculus 1. And then now I'm going to take a derivative for that. So now this is fundamental. So this is part 1 here, right? Now part 2 is take a derivative after that. So like I said, in my situation, it's never perfect. And you know why it's never perfect? Because if I ever take a derivative of this, what is d to the dx of big G of sine of x?
What? Say that again.
G of sine.
Lowercase of sine of x. What else? No.
Oh, times one. No, times
Times cosine of x. You have to make sure there's a chain rule, because you take a derivative inside, you have to take a derivative outside. Now let's practice again. What's the derivative of the second one?
G.
G of what?
Cosine of x.
Good.
Times negative sine of x.
Oh, good. Then we know what is this situation, right? What is G of sine of x?
Excuse me?
What G of sine of x? If G of t is equal to square root 1 minus t squared. So what's G of sine of x? Just substitute t with sine of x. 1 minus sine square of x, good. What is G of cosine of x?
Sine squared of x times negative.
This one turns out that this is the exact same question Sarah called me. It's like, Mr. Yi, I don't know how to do this. I said, I teach you in class. Leave me alone. You're in University of Chicago for a reason. You're supposed to be smart. Figure out. Okay, what is 1 minus sine square?
Sine squared. Oh, let's see.
It's actually turned out pretty nicely.
The whole process.
So square root of cosine square is just cosine x, right? So it'd be cosine square of x plus sine square of x. The answer is 1.
All that just to get one.
That's
That's the only number.
Is that always gonna get 1? No, not always. you might get some type of expressions because in this case, your expression is supposed to be cosine square of x plus sine square of x.
Actually, I can explain. You got
What?
explain like
Yeah,
how you get from g of x, g sine of x to radical 1 minus sine squared of x.
Oh, because you already assume this, right? So you assume this part, right? Can I plug in sine of x here? So it'll be 1 minus sine square of x. Square root 1 minus sine square.
Wait, say that.
You have cosine squared. Square root and you get cosine.
Oh, yeah.
Okay, so so hold on a second. It's gonna be integration, let's say sine of x and the x squared of 1 minus t squared dt. And I always say, can you find f prime of x? Now, when something is constant, let's just do pi. Let's do pi. Pi is fun. Let's just do pi. So here's the questions. You have 6 minutes to figure out. 4. Go.
Yeah.
Does anyone actually understand how to do this?
Follow the process that we just did.
So the whole key thing is you don't know how to integration of square root 1 minus t squared. And then since they are taking derivative following that, so you just assume that's a function. Now, if you assume that's a function, we integrate, so you don't have to know how to integrate square root of 1 minus t squared. Just assume that function, you integrate, use the expression. When you integrate from a g, lowercase g, it will become uppercase g. Now, when you take a derivative, you have to understand,
Wait, can you see that last part?
you take an integration, you assume a function g of t, and then you integrate it, so it's going to be a capital G. But after that, you're going to take a derivative, it will go back to that. But then there's a chain rule. The problem is a chain rule. The problem is not the thing. It's a chain rule. That's the issue.
The problem is just remembering the steps. I mean, to get out.
It's not memorizing a step. You are understanding what's going on because you're not able to take integration of this function. So we're going to assume a function and we can integrate that. And then we can take a derivative of that. It's only chain rule is making a big difference. So make sure the chain rule apply here.
Right.
Do you assume that 0 minus t squared equals g of t?
Yeah, it's g of t. Somebody try to airdrop me something.
Wait, so g of t on the last problem was square root 1 minus
T squared.
squared. So it had the square root in it, right?
Because I take the whole thing. I'm just going to assume that's the whole function. I'm going to integrate it. And I'm going to take a derivative of it. And the only thing I have to care about is the chain rule part.
Okay, 2 minutes. 2 minutes.
What's the derivative?
Let's do it to pi. That's a good question to ask yourself. Anybody can help her?
Oh wait, I know this one. I remember this one. Yeah,
What's the derivative of pi?
it's 3.
Dude,
1. It's 1. It's 1.
It's a constant.
Yeah, so it's 1.
It's
No,
0.
So it's 0. I got this.
It's okay.
No, it's bad because I knew that one last time we were doing derivatives.
So I know how you feel when a kid doesn't know how to factor, right?
Yeah, yeah. So you know. That's why I said I felt like you. And I was just staring at him.
All right, so I will get probably integration of g of t dt here, and between pi and sine of x. And now I'm going to take a derivative on both sides of f prime of x. That's going to be big G of sine of x minus big G of
I'm not done yet.
pi. And I'm going to take a derivative of this. So it'd be G of sine of x times cosine of x minus G of pi times 0. This part is going to go away completely. So that's going to be 1 minus sine square of x times cosine of x. That's equal to cosine square of x times cosine of x. That's equal to 1 over cosine of x, which is secant of x. It's going to review of all the stuff.
Yeah.
I was prefer red in the game last night, so
Oh, is she okay?
yeah, she's just saying she's coming to her this morning. She's not here.
Oh, told her to watch your video. Uh-huh.
No problem. If there's no like root, like why can't you just move those up to the top and integrate it?
Which one? For the first one?
Yeah, because like this one has the square root, so you can't. So like, why not for this one? Why can't you just like move it up and then
You
integrate?
can integrate because you can't really integrate. I mean, it's not like saying you cannot integrate, don't do this. It's easier to do it this way. So it'd be 1 minus t squared, right? To the negative 1. You don't know how to integrate to the negative 1 power here because you need a natural log. And also u equal to negative t squared, du is equal to negative 2t dt. But if you do that, right, this is going to get u to the negative 1, and this is du over negative 2t. The problem is there's still negative 2t on the bottom. So you can't really integrate that as of yet. And even that, even is there was 2t's, there was, even that, even you know natural log, it still had to do something else. You had to do actually something called decomposition of fractions. So you